Isotopes are different forms of the same element. So atoms with the same number of protons but different number of neutrons. And if they have a different number of neutrons, then their mass number will be different. So here is an example of some isotopes. You'll notice that all of these have a proton number of 1. That makes each of these a hydrogen, because hydrogen is defined by its number of protons. So hydrogen is always atoms that have 1 proton. You'll see that in this particular case, they all have 1 electron, but their number of neutrons vary. So in this first example, our hydrogen has no neutrons. Therefore, its mass number, which is protons plus neutrons, is just 1. The atomic number is still 1 because, again, that's the defining feature of hydrogen, but this hydrogen only has a mass number of 1. It's basically just a proton and an electron sort of floating around. This second hydrogen, still 1 proton because that's what makes it a hydrogen, 1 electron, but in this case has 1 neutron. So the atomic number is still 1, but in this case the mass number will be 2 because, again, mass number is protons plus neutrons. And our third isotope is this last hydrogen, who again has 1 proton, but in this case 2 neutrons. So again, atomic number 1 because it's still hydrogen. This is its defining characteristic, but it has a mass of 3 because it's protons plus neutrons. So all populations of atoms have variation. So not every hydrogen has the same number of neutrons. Not every carbon has the same number of neutrons. Not every fluorine has the same number of neutrons. And they all have isotopes that exist. In fact, if you look up each element, oftentimes you'll see how many common isotopes of that element exist. So there are some elements that have 32 different isotopes, meaning that 32 different numbers of neutrons exist for that particular element. When we are noting isotopes, there are certain ways that we can write them so that everybody knows that we're looking at a particular isotope of hydrogen. So if I said you were looking at a hydrogen atom, it'd be better if I could be more specific about which of the hydrogen atoms we have, which variant of it we have. So we have something called hyphen notation as a way of noting isotopes. And so in hyphen notation, what you would do is you would write the symbol of your element and then the mass number. Now, this is where students always get confused. They always want to write atomic number here, but you don't have to write the atomic number. As soon as you tell me it's hydrogen, I know the atomic number is 1 because that is what makes it hydrogen. It's the mass number that is changing between our isotopes. And that is changing because a number of neutrons has changed. So it's hyphen notation is always the symbol of your element and then a hyphen and then the mass number of the isotope that we are referring to. Now, nuclear notation is another way to designate which of the variants we're looking at. So again, you would write your symbol, and then you would write your mass number in the upper left and your atomic number in the lower right. So if I were doing, let's say, carbon, so here are my different carbon variants. Carbon is defined by the fact that it is atomic number 6. It has 6 protons, that's what makes it carbon. You can't change that for a carbon atom. So if I'm looking at it, I'll see that 6 is written in the lower left-hand corner. Now each of these is an isotope of carbon, so they each have a different mass number. So carbon 12 has 6 neutrons, because we know that mass is protons plus neutrons. So if 6 of these are protons, then the other 6 must be the neutrons. So this is one variant of carbon. Another variant of carbon is carbon 13. So a carbon with a mass number of 13. In that case, it has 7 neutrons because, again, that mass number is protons plus neutrons. So 6 of these were the protons, so 7 of them must be the neutrons. And the last one is carbon 14. With the 14 in the upper left, that's your mass number. Again, that's protons plus your neutrons. The number of protons can never change for an element, so it's those number of neutrons that have changed. For me, it's helpful to remember that the small number is lower. So the atomic number is typically the smaller of the two numbers. So small number low, big number high. That's just how I remember which one goes in which place, if that's helpful for you. All right. So I think this is in a different place in your notes, but this is generally what we're looking at when we're looking at the periodic table. Just know that there's no rule about where your atomic number goes and where your mass goes. So the atomic number could be on top, it could be on the bottom, but just so you know, your atomic number is always a whole number, and your atomic number is typically the smaller of the two numbers.